Hello everyone. In this video, I will introduce our paper entitled Diagnosing Pretrained Models for Out-of-Distribution Detection. We studied the problem of OD detection, and the typical case is in image classification. We have a training set containing several training classes. Then, during testing, test samples can belong to training classes, which are ID samples. They can also belong to training classes, which are semantically out-of-distribution samples. The aim of OD detection is to separate ID and OD samples during inference to ensure a safe prediction. A general pipeline for OD detection is like this. During training, only ID samples are provided for training ID classification models. Then, during testing, we want to design an OD score function based on the ID models to separate ID from OD. In such a pipeline, ID pretrained network is a critical part in OD detection, and previous works always assume that a good ID classification model should do well on OD detection. However, we find a different trend in ImageNet pretrained models. V2 models with better ID accuracy show worse OD performance than V1 models. This challenges the assumption that better ID models should do better in OD detection. We have two questions. The first is why V2 models with better ID accuracy performs poor in OD detection than V1 models, and then how to fix those pretrained V2 models in OD detection. So compare V2 and V1 training receipts. Several data augmentations are added. There are two data-based augmentations, random erasing and true augment, which only change the input data, and also two label-based data augmentations, label smoothing and mix-up, which change the input data and also the labels. We add data augmentations on the basic V1 model, and each time only a single data augmentation is added. We observed that label-based augmentations, label smoothing and mix-up, improves ID but harms OD performance, and the harmful impact is mainly in the output-based OD performance, MLS, where feature-based OD performance is less impacted. Based on the observation, we propose a quick fix named augmentation delete, as label smoothing and mix-up mainly influence the output logics rather than features. We can just frozen features and fine-tuning the last layer without any data augmentations, and this approach is simple and efficient. It can be applied to pretrained models quickly and improve OD performance of V2 models by a large margin. See the orange dot in the figure. Then, as label smoothing and mix-up impact pretraining process, a more general approach is to fix pretraining receipts. For the mix-up, it can be viewed from virtual sample generation. As mixed coefficients becomes larger, mixed samples and OD samples become less distinguishable, suggesting that mixed samples can be viewed as virtual OD samples. Then, adding mix-up to basic V1 model will reduce the separation between ID and mixed samples. As we see mixed samples as virtual outliers, poor ID mixed separation will indicate poor ID-OD separation and also poor OD performance. We aim to introduce a new virtual separation loss LVS to encourage large separation between ID and mixed-up samples to fix mix-up. LVS is in the form of binary classification. It wants to ensure the ratio between ID and OD maximal logics to be like this equation, which is larger than 1. And the larger the mix-up strength, the greater the ID mix-up ratio and also the separation. After introduce the virtual separation loss, we have larger ID mix-up separation and better OD performance. Our final training-based approach, augmentation revise, can improve various OD scoring methods and show total results on different datasets. So, to draw a conclusion, we identified that label smoothing and mix-up harm OD performance of pretrained models, and we propose both a quick fix and also a train time fix for fixing pretrained models. Thank you.